Assalamu alaikum students. Today we are going to cover the lab number 10, which is on BJT characteristics curve, right? So we are going to be discussing the DC characteristic curve of your transistor, right? And definitely NPN and PNP both scenarios will be covered on the theory side, right? Kind of because you skip the lab in which we will be using multimedia और उसके through आप अपनी NPN and PNP transistor को check out कर सकते हैं. But because you skipped it, so I will be still giving you the view कि आप उसको check out किस तरह कर सकते हैं using multimeters, right? When you have a transistor and a multimeter, how are you going to check your transistor, right? So किसी भी transistor में there are three sets of जिसको हम कहते हैं legs, three legs. It has three legs, which is one of them is emitter, next is base and collector. Now इनकी जो orientation है, it can be altered, ठीक है? ज़रूरी नहीं है कि the first one is always emitter, it can be base as well, ठीक है? So orientation checking के लिए भी there is a procedure. I am going to discuss two methods with the help of which you can find out which lead is emitter, base or collector, right? So first of all, where should be your knob of multimeter, right? So in the first method, you can set your multimeter knob to the diode setting, right? And if you want to check out whether your transistor is an NPN transistor or a PNP transistor, उसकी जो दो leads होती हैं उसमें से if you connect your positive lead with the base and your negative yes, if your positive lead with the base and your negative lead with emitter or collector, in both cases you receive a specific value or a reading, it means that your transistor is NPN. But if you reverse the setting in this position somehow, okay, so you are connecting your transistor in a position that your positive is connected to the midpoint and your negative is connected to either the emitter or the collector, and you are getting a reading, it means that your transistor is an NPN transistor. ठीक है? इसी transistor के लिए if you flip the connections and you connect your negative to the mid terminal and your positive to first emitter and then collector, in both cases you will either receive a open loop or a one, क्योंकि आपकी within your lab you have this specific type of multimeter जिसके लिए one means that your range is kind of you have out of range आ रही है आपकी value, right? So then you जिस तरह आपने perform किया था and you observed that when you increase the range that one was removed and a specific value was observed on your multimeter, right? अच्छा, this is the scenario for your NPN. PNP में क्या होता है? In PNP scenario, because your midpoint is your negative terminal and the other two are your positives, so current is flowing from your collector to your base. In this scenario it was from your base to emitter or base to collector, right? इस scenario में क्या था? From your collector to base आपका current flow करता है, so it's the flip opposite direction. तो इस सूरत में क्या होगा? Your mid terminal base is N, so you will be connecting your negative lead with your mid terminal and your positive lead with your collector or emitter, and both scenarios में when you connect your positive lead with either collector or emitter, you will receive a value, which means that it is kind of confirming that it's a PNP, right? And now you flip the connections and you connect your mid with positive, okay, and the other two collector and emitter with your negative. And in this scenario, if you observe an open loop, it means your transistor is working fine, okay? एक side पे it's showing a value, and in the other side or the other, if you flip the connections, it's showing open loop or one value, okay, for your specific multimeter within your lab, right? So it means that it's a normal transistor. It is functioning in the forward bias, and in the reverse bias it's kind of open loop, so there's no defect in the transistor, and plus you can test your transistor in this procedure. So what's the other method? Every multimeter, most of them, right? Yes, the previous models में अब ये नहीं होता, but present models have a specific setting of HFE, right? Now instead of diode, you are going to set your transistor to HFE setting, and on your transistor are the specific set of NPN, NP, NP poles, holes kind of, ठीक है? And what you are going to do, इसमें आपको बताया भी होता है emitter base collector, emitter base collector, and ऊपर mention होता है if a transistor is NPN, you don't know when you have a transistor. Either you can confirm it from the data sheet of the transistor, which you can check out by the number shown on the transistor, right? And whether it's 2N3904, right? So you can find out the data sheet which will confirm you कि ये transistor NPN or PNP. But if you don't have internet, right, and you have to confirm it out, you can confirm it out with the help of a transistor multimeter, right? So when you set your transistor in HFE mode, आपने अपने ट्रांजिस्टर को कनेक्ट करना है by putting it in first emitter base collector of NPN, right? If it's showing a value in this scenario, it means all the three leads are connected to the correct point, which they have, which is the actual point, and your transistor is actually an NPN transistor with the emitter as first lead, base, and collector, right? Other option is you can connect it from starting from here with base, collector, and emitter if the values are not shown, right? So you will connect in this form from this for the same NPN position, right, with the base, collector, and emitter. अगर इस सूरत में आपके पास values आती हैं, so this is the kind of version, and इसमें आपकी first one is the base, mid one is the collector, and this side is the emitter, right? इसी तरह if none of these two positions are showing value, then you will move for your PNP again. Either use first three leads or the next three leads, right? जिसमें आपकी value आएगी, that's the actual configuration of your transistor, that's the actual emitter base collectors of your transistors, right? And HFE is actually a gain, current gain, but it's specified to the DC gain, or you can say beta value, right? Anyhow, let's move toward your lab side. You should be clear with this scenario, how you can find out the emitter base collectors of your transistor by the method 1, okay, or by the method 2, and how you can test it using multimeter. So this is our graph which we want to plot, but with the help of multisim, okay? So two types of characteristic हैं. One is between the output current I collector and the output voltage VCE, and the other graph is between input current IB and the input voltage VBE, right? ये दो graphs हैं जो हमने plot करने with the help of multisim, right? So this is our circuit for this specific scenario. अच्छा, the theory is ये जो सारी theory है, that's for when you are dealing with your hardware, right? Then you kind of calculate the formula value and you put it out and observe it with the help of multimeter. आप actual circuit पे उनको check out करते हैं, right? So now presently we are going to need transistors, resistors, and VBE, right? Let's start the experiment. Now I want a single transistor. Let's use the one which is used in your lab, which is 33K resistor and 100 ohms, right? And a 2N3904 transistor, right? So let's go for 2N3904 but specified transistor. You are going to find it in transistor. Okay, एक दो resistors हमें चाहिए. Let's take any two, right? And this is my entire connection, right? And indicator is the thing which I will be adding later on. Let's change the values. Your output resistance is, now I will, or I can ask, okay, why is the output resistance 100 ohms and why is the input resistance so high? Because you should know why they are choosing such values, right? So this is 33K. Now that's mostly because of the fact कि आपकी input side पे they want to extract the maximum voltage from the source, right? जो भी voltage आ रही है, the maximum of that should be extracted. And I also want to in output पे क्या होता है, whatever voltage is generated, it shouldn't be dropped across the resistor of the transistor, right? So that's why they use a lower value there. Acha, I want to place two indicators, one for current here and the other one for this location, and two sets of voltmeter. Okay, so this is my entire connection. अच्छा, ये जो indicators मैंने use किए हैं, that's for your understanding if you want to check out values point by point, ठीक है? And अगर आप वो scenario करना चाहते हैं, you can go with this option, right? That's for your ease, ठीक है? अच्छा, अब हम अपना connection complete करते हैं, and then we will go for plotting. अच्छा, ये जो है आपकी वोल्टेज है, दैट्स वी सी ई एंड दैट्स वी बी ई, एंड ये आपके करंट्स हैं फॉर योर आई कलेक्टर एंड आई बेस. इफ़ यू वांट टू चेक इट आउट यू कैन यूज़ इट, ठीक है? एंड लेट्स change the voltage, and I'm for my ease I am changing the label to VB because that's connected to the base side, and this side I am changing it to VCC, right? Let's go for simulation. Acha, simulation में there are multiple options, and we are wanting to observe the DC behavior of your transistor, right? Because DC is the initial condition. अगर आप किसी transistor को DC voltages नहीं देते, you cannot amplify any AC signal with the help of your transistor, right? It's you're working with the system which does not have any power, right? So दो behaviors हमने check करने थे. एक आपका in input voltage with respect to input current, right? And I'm using this source from 0 to, let's say, 10 with a step size of 2, and my output means your y-axis, right? So your y-axis is base current, right? So your input was VBB and VCC is the secondary source, right? So you will see when you are stimulating it, this is somehow your curve. For 0 it's red, and for all the other values it's your orange side, right? This is your kind of behavior for the input side, means this is your input voltage and input current I base, and this is your kind of behavior for your input side, which is somehow familiar with this version, right? 0 से लेकर 1 तक my curve was, and I was changing my VCC, which was my secondary source, right? So somehow my VCC is in this scenario, right? Achha, how I am going to observe my your output curve, right? उसके लिए आपने क्या करना है? Again you are going into analysis, DC sweep, because DC behavior is the one which I am observing. अच्छा, let's observe it from a lower value. Let's say it's from -5, and I'm going to change it to VCC because this is the one which I'm going to plot on my x-axis, right? अच्छा, सेकेंडरी सोर्स के लिए आई एम गोइंग टू यूज़ VBB, ठीक है? एंड यहाँ पे आई जस्ट वांट टू टेक इट टू, लेट्स से 5, decrease it to 3 or 2, let's say. Okay, and my output would be collector current, right? ठीक है? Base को I'm going to remove, so it's a y-axis collector and x-axis VCE, right? So let's stimulate it, and this is somehow your behavior of your from -2 up to 5. आप इसको increase भी कर सकते हैं, and let's observe how much it's familiar with this one. Quite familiar, right? So you are plotting actually your collector current with respect to a collector voltage, and this is the variation is based upon your base currents, right? यू कैन सी बेस करंट की बेसिस पे आपके मल्टीपल ग्राफ्स आते होते थे, ठीक है। सो what if I want you to make a graph, use a graph। अच्छा, इसमें आप ग्रिड भी ऐड कर सकते हैं, यू कैन चेंज द बैकग्राउंड कलर, ठीक है। इसको आप यूज़ करके यू कैन मेक देम थिकर एंड मच क्लियरर, एंड प्लस द मोस्ट important is you have to export them, ठीक है, for all the check all for all the traces for VB 0 2 4 6 and 8 and 10, ठीक है, and you are going to export them and make this Excel sheet, ठीक है। You should be familiar कि if this is the plot, what was the value of VCC, what was the value of current IC, and what was the base values, ठीक है। या आप if you want to verbally draw it, that's also fine, ठीक है। अच्छा, make it, ठीक है, this version, and then you are just going to, this is your actually x-axis which was VCC, ठीक है, and this is your y-axis which is your current in milli amperes, right, ठीक है। and similarly ये आपका x values हैं and your current for your VBB equal to 2। अच्छा, calculate the collector current, right? If VBB equal to 2, you have to calculate the collector current for all the scenarios। VBB is equal to 4, is equal to 6, is equal to 8, is equal to 10, that's the VBB। what's the I base current, ठीक है, that should be in microamperes or milliamperes, जिसके लिए you are plotting this curved line, ठीक है, that's the only thing which is not mentioned here। so you are going to calculate it and write it in your graph, and this graph, this data sheet as well as both the graphs with their data sheet should be included in your lab part, right? so this is all for your lab number, which is lab number 10, right, of your DC characteristic curve of BJT। so Allah Hafiz।